Good afternoon. Today we are going to see the questions which may be asked on columns and combined loading. Now, on columns, we have two formulas. So, column two formulas. Now, we have one formula that is for a long column. We have column long when we have L effective upon least lateral dimension. Least lateral dimension. Generally, it is B dimension. If greater than 12, then we have long column. And for this, we are going to use Euler's formula. PE is equal to pi square EI minimum upon L effective square. Now, unit of PE, we have kilonewton, Newton, kilonewton. Unit of E, Newton per mm square. Unit of I minimum, mm raised to 4. And unit of L effective square. And L effective unit, we have millimeters. Now, columns, actually we have two types. One is short column, which failed by crushing. Fail by crushing. And another we have long column which fails by buckling. Long column fail by buckling. Fails by buckling. So in this we have long column, we have four conditions. First condition, we have both end hinged. L effective equal to L. They may ask you to draw the diagrams. You should be in position. One end fixed, other end hinged. So we are in this fashion. So we are likewise. So you can see where we have fixed, we have to show zero slope. So total length is L. L effective equal to L by root 2. We have both end fixed. Again, this is L. Now we have to show zero slope on both sides. And we have L effective equal to L by 2. And then we have last one end fixed, other end free. Then we are in this fashion. This is L. L effective equal to 2L. So we have this four boundary condition. Important, we have to consider I minimum. Now, if I will consider, already we have this problem. Many of the students made mistake in this one. They have calculated Ixx. You have to calculate Ixx. You have to calculate Iyy. And minimum of the two you have to consider. So minimum of Ixx, Iyy. Then we have second formula, which is Rankine's formula. Rankine's formula. And this formula is applicable for both. We can use it for short column and we can use it for a long column. So we can use this formula for both type of columns. Now we have PR that is equal to sigma C into A divided by 1 plus A into lambda square. Now sigma C we have yield stress or crushing stress. We can write it as crushing stress or yield stress. Unit Newton per mm square. Crushing stress Newton per mm square. A is area, millimeter square. A is Rankine's constant. And it is given by sigma y upon pi square E. Now it do not have any unit, no unit. Because we have sigma y and we have E, units gets cancelled. And this value is generally depending upon your material. Value of sigma y. You can take this sigma y or you can write it as sigma c, one and the same. Whatever you are going to write in numerator, same you have to consider in this also. And then lambda, we have lambda is equal to L effective upon R minimum. And lambda square, we have L effective square divided by R minimum square. Now we have R minimum square equal to I by A. Or you can write R minimum equal to under root of I by A. And you can write this value directly, lambda square equal to, if we will put it here, then we have A into L effective square divided by I minimum. This is again important one. This is I minimum. I minimum. And likewise, we have to solve the problems which are related with columns. So these questions may be asked in oral examination. Then we have second part of this is combined loading. So we have combined loading. Combined loading. Now in combined loading, we have simple formula that is sigma equal to sigma axial, or it can be written as plus minus sigma bending. So sigma axial sometimes may be written as sigma direct. So sigma A is given by P by A and sigma is given by plus minus M by I into Y. Now how we will consider this? This is most important one. So if I will consider a column and let us we have this will be column. Now if you have, now we will consider this A, B, C and D. Now if we have load on this side, so we have P and this distance we will say as X. So now we have A, for all we have value that is sigma A we have same. So I will write it by other color. So we have everywhere sigma A that is plus. So I will write sigma axial or sigma direct I will mention. Sigma D, we have sigma D and we have sigma D. Now if I will say this as x and this as y. Now we have bending about y axis because moment is about y axis. Then where we have plus sigma by and where we have minus. So now we have eccentricity on B and C side. And therefore on this side we have tensile. So this will be minus sigma by. So here we have plus. So because P we have on right side of Y where we have B and C. So this P developed B and C compression stresses due to bending and tensile stresses due to bending on A and D. So this will be plus sigma By. This will be plus sigma By. And then this will be minus sigma By. So likewise, column to which corners are nearest, that corners will be developed as compression. So why this will be compression? So it will be bent in this fashion. So likewise. And therefore we have tension on A and D and compression on B and C. Now if we have this column with both eccentricity. So now just I will plot with both eccentricity. That is along X also and along Y also. So let us, we have column somewhere here. Now we have this distance as X and this distance as Y. Now this is y axis. We have this as x axis. Now we will start with, we will write the corners. So we have A, B, C, and D. Now we know we have sigma D. We have same for all. So I will write sigma D. Then we have sigma D. Then we have sigma D. And then we have sigma D. Now we are going to now first consider sigma Bx. That is due to, for X means bending moment, we have P into Y. So when we have bending moment XX and the column is near to D and C, so we have this will be plus sigma Bx. We have plus sigma Bx. Then automatically, because it will bend in this fashion. And therefore we have compression, that is ADC, and tension we have, that is AB. So we have this will be minus sigma Bx, and then we have this will be minus sigma Bx. Now for Y, we have column on this side, so it will bend in this fashion. So BC will go in compression and AD will go in tension. And therefore we have, so I will just change again the color, and then we have this will be plus, sorry, here again we have minus sigma By. Here we have plus because we have compression BC. So plus sigma By. Then we have plus sigma By. And then we have this will be minus sigma By. So likewise, we have to decide the stresses. So this corner, we have both tension due to X and Y. Here X tension, Y compression, here both tension and compression because it is closer to C. So likewise, we have to decide the stresses. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.